Okay, this video goes over chapters 13 and 14 homework solutions. Out of chapter 13, you're supposed to do problems 3 and 6, and then out of chapter 14, do problem 4. So problem 3 out of chapter 13, they give you some data, and what they're wanting to know is what is the relationship between how much natural gas we use based on how hot or cold it is. And they give you some output. That's really not as important. I want you to start with the data file. So if you go grab the data file, this is what you get. You get your temperature. I'm going to go ahead and be real explicit and emphasize that what the cause is the temperature, and the result is the how much gas is consumed. With the thought is that when it is really cold, you use a lot of gas, and when it's warm, you don't use so much. So we know how to build a scatter plot. This is chapter 3 stuff. We can always go build a scatter plot of this, like that. And we can right click on any data point. Go ahead and get the equation like that. And so that is the least squares point estimate. That is B0 and B1. So B0 is the intercept, B1 is the slope. So in this case, this would be B0, 15.8, and B1, the slope would be minus 0.129. You could also use, so B0, and B1. B0 is the intercept. This is the slope, or coefficient of the temperature. And we could use a formula called intercept. Go grab your y's. Grab your x's. There's the same number as this one, and do the same thing with the slope. You definitely have to grab your y's first. So that's two ways. You can do it this way, you can do it this way. Remember what the slope is. The slope tells you for a change in x, a unit change in x of 1, this is the result in y. So if the temperature goes up by 1 degree, the gas consumption would go down because it's negative by 0.127, whatever the units of measure is. Here's another way. This is what you need to start using the data analysis add-in. The data analysis, go down to regression. It asks you what is the y range. I'm going to grab the label, so I'm starting in row 1. The x range, I grab starting in row 1. I tell it that this labels, and I'm going to go ahead and put the output on this spreadsheet like that. And I'm going to zoom out a little bit. So the same thing, your r squared, there's the r squared. But we also have some new information here. We've got this, and we got this. This is the p-value. We've got these two. Which are the slope and the intercept, or intercept and slope. So you can also do your 6 hypothesis steps. So when you're doing regression, step 1 is that the null hypothesis is that the slope equals 0, and the alternative hypothesis, is that the slope is not equal to 0. Step 2, you set alpha. Step 3, you calculate your statistic. There's 2 that you can look at. We're going to focus on the F stat. So F equals this. Step 4, get your p-value. and that's equal to this. Step 5, conclusion. Since the p-value is less than alpha, we reject H0, which means that this slope is statistically significant. It means that there is a relationship between temperature and gas consumption. It's not just noise. So you can say that temperature does affect gas consumption. Okay, so that's 3 different ways to get the least squares point estimate, and then they wanted you to predict. So they wanted to say, and I'm going to do it down here and you'll see why. If x equals, and I'm always going to put a 1 there, and then I'm going to put the 40 there. And then if that's true, then y equals, and it's going to be, I'm going to use the sum product of these 2 different arrays, this array or this vector and this vector. And so what the sum product does is take this times this plus this times this. You always put a 1 on the intercept and then whatever the input that they wanted, the 40. And so this would be the gas consumption. And again, we've solved for this before earlier on, but that's this. All right, let's do the same thing in 13.6. They give you the data. You could certainly build, what we're looking at is how does the labor cost change based on the batch size. Now if you were going to build a scatter plot, here's the wrong way to do it. Don't do that because you're plotting the batch size on the vertical axis. If you're going to do this, you need to copy this over like this and build a scatter plot of that. You put the labor cost or the y on the vertical axis, not the x, the horizontal. But I'm going to use the data analysis. We use the data analysis regression. I'm going to go grab my y range, and I'll do it like that, and then my x range like that, and I'll put the output on this worksheet. Whoops. Oh, I'll put right. Unbelievable. Let's put this, sorry, there. And then this needs to be there. That should work. All right, there's my output. So same thing as before. Let me go over and copy it over to get started. My null hypothesis is that this slope is 0, and then I'm trying to prove that it's not equal to 0. I set an alpha. My f-stat will be this. My p-value will be this. That's in scientific notation, so that's 5.04 times 10 to the minus 17, which means I need to move my decimal places 17 places to the left, which puts 16 zeros, which means that's a very small number. So p-value is small, and reject that. So your conclusion is that the batch size does affect labor cost. You can also discuss R squared. R squared is equal to this. And again, that's a stupid high number. You'll never get an R squared. Remember, R squared is a number between 0 and 1, so that's really high. So yes, clearly the batch size affects labor costs. Then we can use this to predict. So if we look at 13.6, they want you to predict the if you have a batch of size 60, what would be the labor cost. So if x equals, and I'm going to put a 1 on the intercept, I'm going to put 60 there, and then my Y, which is my labor cost. These two numbers. Whoops. These two numbers against these two numbers. That would be my labor cost if my batch size is 60. All right, so that's that one. Let's move on to chapter 14. Chapter 14, what makes this unique is that it is more than one independent variable. We have two independent variables. So we can't use scatter plots anymore, because scatter plots only do one variable at a time, and we don't want to do one variable at a time. When you have more than one independent variable, you have to use multiple regression technique. So that means that you have to use the multiple regression data, or the regression in data analysis. So if you get a multiple regression problem where we have two independent variables like this one, and this one is problem 14.4, they give you the data right there. You don't want to build individual scatter plots. You don't want to look at these one at a time. You want to do multiple regression, which is what this is. So how do we do that in Excel? We go under Data Analysis, Regression. The Y range is the sales price. Before I do this, I'm going to do this real quick. I'm going to do something. I'm going to concatenate, or I'm going to make this equal to, here, I'll show you. I'm going to combine this cell and this one so I get them both. Equals this, and then I'm going to concatenate it with a comma, space, comma, and this. So now I get sale price Y. I get both of those. Same thing, I get home size X1, rating X2. Now I'm going to go do my data analysis. Here's my Y range, but look at my X range. It is 2 columns worth. When you do regression, you only have one column of Y. You always have just one variable on Y. But on multiple regression, we can have multiple columns, multiple variables. We can have a lot. The very first row that I selected was not numbers, it was a label, so I'll make sure this is label, and I'm going to go ahead and put the output on this worksheet. Right there. Okay, a lot of information now. So now we're going to focus on this. The first thing to look at is the ANOVA table. This right here, it's the same thing as before. Your null hypothesis is that, let me bring that over. The null hypothesis is that all of the slopes, slope 1 equals slope 2 equals 0. We assume that they're all 0, and then our alternative hypothesis is at least one of them is not equal to 0. So what ANOVA tells you, what this ANOVA tells you is that all we do is that we just try to prove that one of them is not equal to 0. Or that's what ANOVA will tell us. We set alpha and we get our F. So there's our F stat. We get our p-value. We can reject the null hypothesis because that's a very small number. It's much smaller than this. So what that tells us when you have multiple regression is at least one of the variables affect sales price. It doesn't tell you, so that's what you get. So that's what step 6 is. And just like ANOVA, when we did ANOVA when we were doing means testing, you got to keep going. So the next thing we look at, so we've looked at these. Now we go up and we look at these. And we're not just looking at R squared now, we're looking at adjusted R squared. R squared is high, so that's a really good fit, and adjusted R squared is really close to R squared, so our models are efficient. So we look at both of these. Then we go down and look at the individual p-values. We look at both of these. And the one that's the smaller is the one that's the most important. So that's a smaller number. Let me do something and not show these in scientific notation. Let's put these in regular numbers and put a lot of decimals. There you go. So you can see this number is much smaller than this one. So that means that home size is more important than rating. So both are important. Home size is more important because it has a small p-value. If it's bigger than 0.05, if the p-value is bigger, generally it's not that important. So if these were bigger than 0.05, we would say they're not important. But because they're both less than 0.05, we can say that, and then the smaller, this one's more important. So you don't look at these to determine which one is important. You look at these. Then, over here is the final thing we're going to do. These are the coefficients. I guess this one also, that's the intercept. If we had to build the least, our equation is b0 plus b1x1 plus b2x2. Well, there's b0, b1, b2. So now we can use this to predict if x equals, and we always put a 1, and then what the problem is wanting us to do is find an estimate if the house is 2,000 square feet and the rating is 8. Okay, so the rating is 8. The question is do we put 2,000 here? That is not right. We don't want to put 2,000 because the units of measure on the home size, these are in hundreds of square feet. These are in thousands of dollars. There's not a house out there that you buy for 180 bucks. That's 180,000. This isn't a house of 23 square feet. It's 2,300 square feet. So when they give us the data and they say a 2,000 square foot house, we can't put 2,000. We need to convert this to the data that was the model was based on. So we put 20. Then our sales price, and we can use the sum product formula like what we used previously. Grab these. Whoops. Grab these, comma, against these. That's how much the house would sell for in thousands of dollars. So 172,000 of dollars. Same unit of measure as these. Okay, that's the homework, the regression homework solutions. Thanks.